Number 14, the period t of a pendulum as a function of its length L is given by this expression, the equation right here. We write the expression for the period as the product of a simplified coefficient term and a variable term using only positive exponents and rationalizing denominators. Then write the approximate formula with a coefficient term rounded to the nearest hundred. So we're going to simplify the whole thing here. So we're going to start by writing the equation. T equals 2 pi times the square root of L over 32. And the first thing we can do is actually simplify the top and the bottom, actually. And the rule is on the bottom of a fraction, again, we cannot leave the square root or any root. So in this case, we have a square root of 32, and that's more than 4, but less than the next perfect square, which is going to be 32 times 2, which is 64. So we need to actually rationalize it to bring it to the next perfect square. Since 32 is not a perfect square, we're going to multiply by 2 on top and bottom. So we have the square root of 64 on the bottom. And on top, we can combine the L and the 2, so we have 2L. On the bottom, we're going to have square root of 64, which is 8. So we have 2 pi's times the square root of 2L over 8. And now we can just simplify 2 and the 8. We can cross it out, and we have pi square root of 2L over 4. And since we want it in terms of L, we're going to separate the L. And so we're going to have pi times radical 2 over 4 times the square root of L. And then we can actually go ahead and follow the directions. It says approximate the formula with a coefficient rounded to the nearest hundredth. That means 2 decimals. So we're going to turn the left side into the expression here into, plug it into the calculator. That's pi times the radical 2 divided by 4, which is approximately 1.11 square root of L. And that is the formula given in terms of L with an approximated coefficient.